Inverse of cotangent function. Does the inverse of cotangent function exist? Let's find out with the help of a cotangent function. First, look at the values of cotangent function for some standard angles. You can pause the video to read the table properly. From this table, we can say that the cotangent function is not defined for all multiples of pi. So, the graph of the cotangent function looks like this. In the graph, we can see that there are no curves for minus pi, pi and 2 pi because cotangent function is not defined for all multiples of pi. Now let us check whether the cotangent function is invertible or not. We know that if a function is a bijection, which means that it is both 1, 1 and onto, then the function is invertible. First, let us check whether the cotangent function is an onto function. As we can see that the range of the cotangent function is from minus infinity to infinity, that is real numbers. So, if we consider any point on y-axis, we can clearly see that there is a corresponding point on the x-axis. So, the cotangent function is definitely an onto function. Now let us check whether a cotangent function is a 1, 1 function. For this, we will use the horizontal line test. Draw a horizontal line passing through the curve of cotangent function. As we can see, the horizontal line intersects the curve at more than one point. This means that for each value on the y-axis, there are more than one corresponding values on the x-axis. So, the cotangent function cannot be a 1, 1 function. And since cotangent function is not a bijection, so it is not naturally invertible. So, how come we are studying inverse of cotangent function when cotangent function is not naturally invertible? Confused? Don't be. There is a method by which we can make cotangent function invertible, and that is what we are going to discuss now. As of now, we know that the cotangent function is not naturally invertible because it is not a 1, 1 function. So, we can make it invertible by making it a 1, 1 function by restricting its domain, just like we did for the tangent function. Let us understand how we can do this. As we can see that the domain of the cotangent function is real numbers except all multiples of pi, and we know that the cotangent function is not 1, 1 function in this domain. If you look at the graph carefully, you will notice that the curve is repeating itself at the distance of fixed intervals. So, if we consider only one curve, for instance in the interval 0 to pi, we can see that in this interval, the curve of cotangent function passes the horizontal line test. This means that the cotangent function is 1, 1 within this interval. And we have earlier seen that cotangent function is always onto. This means that the cotangent function is invertible in this restricted domain. Or in other words, we can say that the inverse of the cotangent function exists within this restricted domain. Actually, the cotangent function is invertible in any of these intervals. So, the inverse of the cotangent function exists in each of these intervals. The inverse of the cotangent function is denoted like this, or it can be denoted like this. We can read it as arc cotangent. This means that if y equals to cot x, then x equals to cot inverse y. If we look at the graph of the cotangent function, we can see that the range of the cotangent function is real numbers. So, the domain of the cotangent inverse function will be real numbers. And the range of the cotangent inverse function will be each of these intervals because the cotangent function is invertible in each of these intervals. Corresponding to each of these intervals, we get a branch of the function, and out of these branches, the open interval 0 to pi is known as the principal value branch. Therefore, the range of the cotangent inverse function is an open interval 0 to pi. And this is how we write cotangent inverse function. Thus, the inverse of the cotangent function is defined as cot inverse y equals to x if and only if cot x equals to y, where x belongs to the open interval 0 to pi and y belongs to r. Let us now try to draw the graph of cotangent inverse function. As we know that if y equals to cot x, then x equals to cot inverse y. So the graph of the cotangent inverse function can be obtained by interchanging x and y axis of the graph of cotangent function. This is the graph of y equals to cot x. By just interchanging the axis, we can draw the graph of y equals to cot inverse x. So this shaded portion of curve from 0 to pi is known as principal value branch. Any value of cot inverse x within this interval is known as the principal value of the cotangent inverse function.